Welcome to The Explainer. So we're all seeing this new generation of AI, right? The kind that claims it can do more than just spit out answers. It claims it can actually think. But the big question is it really reasoning? Or is it just an incredibly convincing magic trick? Today, we're going to put that claim to the test.
So on one hand, you've got your standard AI. You feed it an input, you get an answer. Pretty straightforward. But on the right, you have these new reasoning models. They don't just give you an answer, they actually show you their work, right? They lay out this whole chain of thought. And the idea here is that this makes them way more powerful. But is that process really thinking?
And that, right there, is the huge mystery we're diving into. See, on paper, these new models look like geniuses. They're acing these super complex reasoning tests. But, and this is a big but, those scores can be really misleading.
Okay, so here's the fundamental problem. What happens if the AI has already seen the test questions before? I mean, if it's already seen them in its training data. It's kind of like giving a student a final exam when they've already memorized the answer key. You're not actually testing if they can solve the problem. You're just testing their memory. This whole issue is called data contamination. And believe me, it is a massive hurdle when it comes to figuring out how smart these things really are.
And this is where things get really murky. Just look at this inconsistency. Over on the left, we've got an older math test. And you can see both types of AI, the standard and the thinking one, perform about the same. But then, look at the right. On a newer test, suddenly the thinking AI just pulls way ahead. So what gives? Is it actually smarter, or is it just that this new test is one it hasn't seen the answers to before? The truth is, the data is so contaminated, it's almost impossible to say for sure.
So to get around this whole contamination mess, a team of researchers from Apple came up with this really brilliant new way to test them. Instead of using, standard math problems that the AI might have just memorized, they built what they call a puzzle gauntlet. It's a series of simple, controllable puzzles that the AI has almost certainly never, ever seen in this exact configuration.
And honestly, the setup is just so clever. They picked 4 classic logic puzzles, stuff the AI probably hasn't just memorized the solutions for. But here's the beautiful part. With these puzzles, you can tweak the difficulty with surgical precision. Like, you can just add more disks to the Tower of Hanoi. And what that lets you do is find the exact point where the AI's so-called reasoning just breaks down.
So their method breaks down into these 4 key steps. First, they generate a brand new puzzle. Second, they can dial the complexity up or down. And then, and this is the game changer, they use a simulator to watch and analyze every single move the AI makes in its thought process, not just whether it gets the right answer at the end. What you get is this perfectly clean, controlled experiment. It finally takes all the guesswork out of the equation.
Okay, so with this setup in place, they ran the tests. They put the thinking models head-to-head with the standard, non-thinking ones. And when they crunched the numbers, something totally fascinating happened. A super clear 3-part pattern just emerged.
And right off the bat, the first result was a total surprise. For the really simple, easy puzzles, the old school's standard AI was actually better, more accurate, and more efficient. Yeah, you heard that right. Forcing the AI to think step by step just made it worse. It was basically overthinking a simple problem.
But then, as they cranked up the difficulty just a little into that medium range, well, the tables completely turned. This is where those thinking models really started to shine. They pulled way ahead. It seemed to show a real tangible benefit to that whole step-by-step thinking process. I mean, they were solving problems that totally stumped the standard AIs. This was their sweet spot.
But that sweet spot didn't last long. As soon as the puzzles got really hard, something dramatic happened. A complete and total performance collapse. It didn't matter which AI it was. They both failed, utterly. Their accuracy just plummeted to pretty much 0. And it didn't matter how much more computer power you threw at it, they just hit a wall, a hard wall.
Okay, but the story gets even weirder. Because it's not just about if the AI solved the puzzle. It's about how hard it even tried to solve it. I mean, logically, you'd think the harder the problem gets, the more the AI would think about it, right? It would generate more steps. And for a while, that's exactly what happens. But here's the really weird part. Just as the problems get close to that breaking point where it fails, the AI actually starts to think less. It literally generates fewer reasoning steps. It's almost like it sees the cliff ahead, knows it can't make the jump, and just gives up before it even tries.
So what in the world is going on inside that black box? Well, because of this super-controlled puzzle setup, the researchers could go even deeper and actually analyze the quality of the AI's thinking, move by move.
So using a simulator for each of these puzzles, the researchers could crack every single move the AI was even considering.
Was it a good move? Was it a dead end? Was it actually getting closer to the solution? For the very first time, they could literally map out how an AI's mind navigates through a problem. And what you're seeing here is basically a map of the AI's mind at work. That green line, that's the golden path, the correct way to solve it. And all those red lines? Well, those are all the wrong turns and dead ends it went down. We can literally watch its thought process unfold, tracking every success and every failure. And doing this revealed some really clear, predictable flaws in how it thinks. So check this out. On easy puzzles, it finds the right answer pretty quickly, but then it keeps going, kinda overthinking and exploring a bunch of dead ends anyway. Then on the medium puzzles, it gets lost down all sorts of wrong paths before it finally maybe stumbles upon the right one. And on the hard ones, it makes one wrong move early on and just gets completely stuck. It fixates on that mistake and can never, ever recover.
Now, all of this was already pretty mind-blowing, but seriously, nothing could have prepared them for what they found next. This is the discovery that really, truly shatters the whole illusion of AI thinking.
They decided to run one last experiment, and it was devastatingly simple. They basically asked themselves, what if we just gave the AI the instruction manual? What if we took away the need to solve anything and just told it exactly what to do, step by step?
The result? Absolutely astonishing. Even when they handed the AI the literal answer key, the perfect, flawless algorithm for solving the Tower of Hanoi puzzle, it still failed at the exact same point. Think about that. The job wasn't about reasoning anymore. It was just about following directions, and it still failed.
This reveals something incredibly profound. The AI isn't really following logical rules, not like a computer program would. Instead, what it seems to be doing is relying on this incredibly sophisticated form of pattern matching. It's not thinking, if A, then do B. It's thinking more like, this situation looks a whole lot like something I've seen in my training data, and what usually comes next is this.
And you can see the proof of this in just how inconsistently it fails. So take the Tower of Hanoi puzzle, a really common problem, something it's probably seen a ton of patterns for. It can make over 100 correct moves before it finally gets stuck. But then you give it the river crossing puzzle. It's actually a simpler puzzle logically, but it's way less common. And on that one, it fails after only 4 moves. That screams that its ability isn't based on some deep general understanding of logic. It's all about how familiar it is with the pattern.
So, what we're actually looking at here is not some flexible, general problem-solving intelligence. It's a masterful, almost magical imitation of one. Underneath all that impressive language, it's a powerhouse of a pattern-matching engine that creates this stunningly convincing illusion that it's actually thinking.
And all of this leaves us with a really critical question, doesn't it? As we start weaving these incredible models into every part of our lives, are we building partners that can genuinely reason with us, or are we just getting better and better at creating the perfect mimic? You know, this research doesn't just put a question mark on the AI, it kind of forces us to turn around and ask ourselves, what does it really mean to think in the first place?